好了，可以。Chapter 4, Integrals. Integrals 就是积分啊 ，derivatives 是导数 ，integrals，yes, the part of calculus related to integrals is called integration, and the part of calculus related to derivatives is called differentiation. Okay, so differentiation, integration. Two kinds become calculus. So calculus consists of differentiation part and the integration part. Okay. When we learn the derivative or differentiation, we consider a particle moving on a straight line. For example, at time t0, the position is s of t0. At some moment, time t1, the position is s of t1. Then we can make the difference quotient s of t1 minus s of t0 and the t1 minus t0. Then the difference quotient. We call this number the average velocity of this particle on this time interval, t0, t1. By mean value theorem, if this velocity function exists, means the position function s is differentiable, then equals sum instantaneous velocity. For example, t1 start between t0 and t1. This is by the mean value theorem. 考虑一个指点在直线上的运动 ，t0 时刻的位置是 st0，t1 时刻的位置是 st1。假如这个速度存在的话，那么根据均值定理，均值定理知道这个平均速度会等于某个时刻的摄氏速度。Okay. So, subtraction, division. If we want to find the displacement, simply by multiplying t1 minus t0. Okay, so this is the displacement here. Okay, if we want to, because velocity sometimes already consider the limit of this difference quotient. So if you want to find the long term from time A to time B, and this particle may be from here, then term that, then, okay. So this is S of A. This position is S of B. If you want to find SB minus S of A, a possible way is to subdivide this interval into, for convenience sake, to some intervals. Such that T0 is A, Tn is B. Okay, this time interval, maybe this particle moved from here to here. Maybe. Maybe. Oh, U-turn to here, and so on. So, SB minus SA equals STN minus ST0. And this displacement is the sum of these vectors. So STN or ST1 minus ST0. ST2 minus ST1. STN minus ST and minus 1. That is, we, how to say that? Insert some terms. Yes, minus ST1 plus ST1, minus ST2 plus ST2. They all can be cancelled. Finally, the same result, the difference of two numbers. Okay, now this one can be used V. By mean value theorem. Okay, why do we do this? Because if T1 and T0 or Ti minus 1 and the Ti, if they are very close, so that the difference is very small. If the velocity function is continuous, then Vti star is almost Vti or Vti minus 1. Because by the continuity, the values of V at here, or anywhere, almost the same by the continuity. So this is the form of summation. I equals 1 to n V Ti star. Yes, just like before, we like to call this delta S1, delta T1. Or if we use the equal size, then delta T. Okay, delta Ti. This is delta T1, delta T2, delta Tn. Okay. So if we want to find the velocity, we use subtraction and division. If you want to find displacement, you can use multiplication and the summation and the addition. This is integration. This is differentiation. Okay. Got it? In fact, if n goes to infinity, we use this notation. Just like before, if passing limit, then we say this is d as dt. D stands for limit. Also, if passing limit, then we use the along s summation s, so stands for the limit of the sum, and use v of t. Again, this we use the dt, and from a to b. Okay, we call this number the derivative if passing limit. Similarly, we call this number the definite integral of f from a to b. Definite integral from a to b. So the definite integral is a number, displacement. And the derivative is also a number, velocity. OK， 好，所以当我们在计算一个质点运动它的速度的时候，我们用相减得到位移，相减得到时间差，相减法跟除法，取极限就得到了导数。当我们要计算什么呢？位移的时候呢，我们可以把这个速度乘以时间，就得到一小段的位移，然后把它加起来，变成了相乘相加取极限，这个叫积分。步骤刚好倒过来就是了，倒过来。好，这个积分呢，我们叫定积分了。这边的积分是定积分 ，definite integral。Definite integral. Okay. So the following is a formal definition. But before that, I would like to give a motivation, because when we talk about derivative from physics, we use velocity. From geometry, the graph of f, we have the rate of change is the slope. Similarly, if we consider the graph of a function f, for convenience sake, suppose f is non-negative and continuous on some closed interval AB. Okay, in order to find this area, we can subdivide the interval AB into small intervals. Equal size. 好，以前在讲到导数的时候，从物理上来看是计算速度，就是位置对时间的变化率；从函数图形来看是 y 对 x 的变化率，就是斜率。那么一样的，在讲积分的时候，从物理上来看，这个位移可以看成为把速度乘以10所有的时间加起来。那么在几何上呢，函数图形上也有对应的东西，就是面积。How to find the area of this enclosed by this curve and these three straight lines? Okay. If we choose some, first we call this one x0, x1, x2, x3, xn minus 1. This is xn. Okay. And in the first subinterval, we choose some point called sample point x1 star. And we use the value of f at x1 star to represent the height of this part. Of course, maybe some error occurs. If x1 star is on the left hand, at the left end point, this error will be smaller than this error. Whereas if x1 star is the right end point, and the area of this small rectangle is greater than the real area. 所以我们要算这个面积的时候，我们可以把它细分 n 等分之后，在第一段里面取一个点叫样本点，用这个的函数代表它的高度，底乘以高的这边取的面积。当然了，这个跟实际面积可能误差的。But if the function is continuous and if n is sufficiently large, then the height here and here almost the same. So the continuity is a very good, a very necessary condition for finding this area. 好，所以说连续性呢是一个最起码的，使这个能够算这个面积的一个条件就是 OK。We do this, and for each subinterval. As you can see, you might see. This sum